There we go. All right, your notes are going to be titled Area Between Two Curves. You hate writing on graph paper, is what you said?
Yeah, because it forces me to space out my words.
Yeah, I'm not a fan either.
Anything what happens? Uh-oh,
Yeah.
it's a graph.
That's the graph. All right, so last unit we would do problems like this. Let's say that's an A value and this is a B value, and I wanted you to find the area underneath the curve, and the curve is labeled f of x. If that was the case, then how would we write? What notation did we use to say represented the area underneath the curve?
Integral.
Mm-hmm. And if we were evaluating this by hand, what would we have to do with the function inside? Yeah, antiderivative. If they wrote, if the function had a lowercase f, and you were finding the antiderivative, do you guys remember how they wrote that? After that? So if they had given us a derivative, like f prime of x, and we were finding the antiderivative, then we would write the antiderivative as f of x. That was one notation. The other was that we started with a function, we found its antiderivative, and then it would be capital F of x. Yeah. So that would mean this is a definite integral, right? Because we have defined what numbers that we want to evaluate it for. So I would say capital F of B minus capital F of A. That's how I would have found the area underneath the curve. And it's, when I say the area underneath the curve, I'm specifically saying between the x-axis and the curve, right? Okay, so that's just kind of review. That's making sure that we remember the notation, what all of that means. Now we're actually going to look at between curves. Thank you. Yeah, it does kind of. Or a fish. That's not like.
Or a DNA strand.
Yes, Patrick.
You guys took it there. Let's not apply math to any other subject area, okay? We don't want it to be too practical and useful.
Exactly.
We want to keep it outside of where it has a purpose, all right? Okay. Okay, so, thank you. So if we wanted to find the whole, if we were ignoring g of x, and we wanted to find the entire area underneath f of x from a to b, how would we write that? From a to b, and then we would just say f of x dx, right? If the g of x wasn't there and the shading went all the way down, that's what we would say, right? Okay. So now if we have to get rid of the little shading beneath g of x because we want to find the area between them, then what should we do? Minus g of x. Now, since both of these are going to be considered together to find the area, we have to put brackets around that. That's like a whole group, and then we're multiplying that times dx. So this notation is still referencing that idea of we find the area using really small rectangles and adding up those rectangles together. And dx represents the width of the rectangle. So maybe it's Maybe on this one we have like 2 rectangles and each width is about 1, or like 1.5-ish. Or maybe we have 3 rectangles and each width is like 1, or maybe we have 20 rectangles and the width is really narrow. And then this part right here represents the height of the rectangle. Hey, Martin, you can bring it. And there's graph paper right there if you need it. All right. So when we do this, we're going to be really careful. This is why we're going to draw sketches for most of the things we do, because we have to make sure that when we find these, we do top minus bottom. Because if we don't do top minus bottom, we're not finding the right thing. All right, so we have to be careful. So we're going to draw another picture so you guys can see why our drawings are going to be important. You guys sure are lucky I don't keep track of tardies. Whoa.
Very complex there.
I know, right? So on this one,
Who would make that?
That's kind of crazy.
yeah, right?
Yeah.
So we have to keep in mind that we have to do top minus bottom. I always feel bad when I see you guys squinting. Let me zoom in real
I
quick.
just can't see.
So for this segment that's from, or this section really, that's from A to B, which function is on top?
F of x.
No, wait, look at it. Because f of x is this line. It's g of x. So f of x is this line. Look at it. This is f of x.
Oh.
Oh, f of x is on top. You guys are right. Okay, so f of x is on top.
Where is it? For A, B.
Alright, Pat, alright.
And then on this one, on the first one, g of x is on bottom. So we're going to do top minus bottom. dx. And what should I put with the integral?
A to
A,
C.
B.
A to b, right? Because it's only on top for this little section right here. And then I'm going to have to say plus the other section, because the function switch places. The other function is on top for the second section. So for this one, I'm going to say, now I'm looking at the integral from b to c, and which one is on top right here? G of x minus the bottom. So that means that when we are finding the area between two curves, we need to sketch the curves because we have to see if one function is always on top or if they switch places. If they do switch places, where's that intersection point to figure out when they switch places? Does that make sense?
What about if you can't, like when you can't see the graph?
Well, so there's two different ways this could show up, right? We could have these problems show up on calculator active, in which case I could give you any function because you could just graph it on your calculator and then know. Or calculator inactive, in which case I'd probably give you functions that you should be familiar with that I would expect you to, yeah, something I would expect you to be able to graph by hand realistically pretty easily, and then you should be able to do that. Okay. All right. Now here's the part that's new. You guys haven't really seen these before. We're going to say... You don't have to draw it as big as I did. Oh, I'm uncomfortable. So this one's going to be a little bit different because instead of finding the area of the curve up and down, we're going to be finding the area under or between the curves from left to right.
Whoa.
Which means that when we're doing the integral, instead of integrating in terms of x, we're going to do it in terms of y. Does that make sense?
Barely.
So, what are the y values that we are integrating from? A to B. We do smaller and then bigger. And then our default is going to be taking the curve that's the most to the right and going straight towards the y-axis. So if you have just one curve, then you would be finding the area between the curve and the y-axis. Yeah, you can do that if you want. So for this one, we're going to say we're going to do right minus left. And so this is going to be f of y minus g of y dy. So right minus left. So sometimes when you look at the picture, it will make more sense to find the integral in terms of x. Sometimes it will make more sense to find it in terms of y. It's going to depend on what the curves look like. If it's going to be in terms of x, it's going to be really obvious because you'll have like an x equals equation. Or they will tell you do it in terms of x. So you'll be able to tell what's happening there. So if you look at, we're going to do a book assignment today, but if you look at these problems right here, 1 through 4, do you think this one is in terms of y values or in terms of x? Should you be doing the area of the curve straight down or left and right? Straight down. Do you guys see how that area goes straight down? Because we have a curve on top and we have a curve on bottom, up and down. So this is going to be differentiated in terms of x, or not differentiated. We're going to find the integral in terms of x. On this one, does it look like it's up and down or left and right? Up and down. Okay. How about this one? That's going to be left and right, right? Because you have a right curve and a left curve instead of a top curve and a bottom curve. Do you see the difference? Okay. How about this one? You could do it either way, yeah, but they didn't tell us these x values right here. Do you see that? We don't have x values here and here to know, like, oh, we're going to find the area between the top and the bottom, and we're going to do it from this x value to this x value, right? So this one's going to have to be from left to right. And that's going to be because we have a right curve and a left curve, and they did give us the boundaries for the y. Okay, so this one could go either way. It just kind of depends on the information they gave you. Okay. All right, so that's what we have so far there. Now, of course, we want to, we're going to do a lot of these with our graphing calculators, and I don't want to just see like 1 through 10 and each answer on 1 through 10 just have one number and then be like, yeah, Miss Rice, I did 10 problems and I used 10 lines and that's all I did. We want to show some work here. Even though most of it's on the calculator, we got to show it. Oh yeah, you guys handed out calculators? So let's go ahead and grab them. Grab your calculators, that's good.
Punch her with the shot. Punch her with the shot, boy. Punch her with the shot, boy.
Unless it's a really
What are you trying?
What do you do with this, boy? You give me a calculator.
Alright, what are we going to show tonight?
So this is what you need to show on Calculator Active because we got to see some work. The first thing you're going to have to show is a graph of the functions.
Yeah, graph. You see that graph?
And for the most part, I want to see it on graph paper. I'm not talking a sketch on notebook paper. I want to see an actual graph on graph paper. I want the points to be accurate. Second, I want to see the integral that will give the area. So if you're looking at the problems that we looked at, these pictures, I want to see a graph of the functions, right? A little sketch of the functions, and then I want to see this work right here so that I can see exactly what you were thinking, okay? And then the third thing is we are going to be finding the area using our calculator. So once you have that information written down, you can just type it in your calculator, and your calculator will give you the answer, right? Do you guys remember how we typed in integrals?
Yes, second. No, math.
Math number 9. All right. So then we're going to say...
DT is the whole 40. DT is the whole 40.
I see DT. DT, go check the road.
So I either want the answer rounded to 3 decimal places, or I want the exact answer, and both of those you're getting from the calculator, math number 9. And this is all calculator active. If this was calculator inactive, how would step 3 be different? Yeah, so step 3, if we had inactive, we're going to say find the antiderivative. And here's what I will say. I've noticed a lot of you guys skip that step. You see that the integral's there, and you immediately plug the numbers in. There's a step in between. We see the integrals there. We find the antiderivative first, then we plug the numbers in. Okay? Some of you guys are going straight here and just like if it said the integral of x squared, you would plug your numbers into x squared. Is the integral of x squared x squared? No, what is it? 1/3 x to the 3rd. Yep. And then we would plug the numbers in. A lot of you guys are skipping that step. All right? So find the antiderivative and then evaluate by hand. So either way, we are always going to show a sketch of the graph and what the integral is that we're actually using. Okay? Every single time. All right. You guys ready for some actual examples? Woohoo! Math. So excited.
Let's just
feeling
say
it.
that it's okay like
While video. Pause. Yeah, this start time. This start time to have like the 30 seconds of no sound. Alright, 1 minute silence for all of our brains.
People aren't listening to you. It's frustrating, isn't it?
Oh.
All right. Examples.
Alright, examples.
We're probably gonna have to pause at some point so I can give you more graph paper.
Okay.
I think there's 4. So y equals x squared plus 1. It's a parabola that goes up 1, right? Anyone know the pattern for how parabolas grow? It's over 1 up 1 and then over 1 up 3. Yep. If you didn't know that off the top of your head, how would you have graphed that by hand? Because this is a fair question by hand.
You just square. That's a fair question by hand. What?
Yeah, you could do these by hand, right? You could graph that by hand. Plug in like -1, plug in 0, plug in 1, plug in, you know what I'm saying? Like plug some numbers in and you can get your points. How do we graph the line y equals x?
Y equals x. So
It just goes in the middle.
Yeah, it goes through the middle. What's the slope? 1. Yeah, up 1 over 1, up 1 over 1. And what part is it asking us to find the area for? 0 to 1.
All the drawing. I think that's really just one unit.
Yeah, just one.
It's supposed to be 1 unit.
Definitely one.
Close to it.
Yeah, close to one. I agree with that. Yeah. So, step 1, make sure that we draw a picture. Now we got to write down what our integral is. So, what are the bounds for our integral? 0 to 1. And now we have to do top minus bottom. So x squared plus 1 minus x. I'm going to put brackets around that whole thing. What do I put on the end? dx. Okay. And if this is calculator active, what are we doing next? If this is calculator active, plug it in on the calculator. All right. So we got math, number 9. Plug in from 0 to 1. I'll go ahead and make sure you can see what I'm typing. I got x squared plus 1 minus x. Can you see I'm typing it in like it looks on my paper? You just got to be careful because since we are subtracting things, you want to make sure that whatever it is you're subtracting, if there's more than one, you either put it in parentheses or you make sure to distribute the negative yourself. That makes sense? When we subtract multiple things, you got to be careful about that. So, okay, so we've got that. Now, is this one where we have to round the answer, or could we get an exact? It's probably some type of fraction, so let's hit math. Math frac. Math frac. All right, 5, 6. So the area underneath the curve, or between the two curves, is 5, 6. If you were doing this one by hand, you might have put it in the correct order and just said this is x squared minus x plus 1. You might have said that, right? And then by hand, what would you have done next? The antiderivative. So we would have had 1/3 x to the third minus 1/2 x squared plus x, evaluated from 0 to 1. Right? So just make sure that if you're doing it by hand, you're being careful. Lots of people on the test were like, let me just plug in 1 and plug in 0 and subtract them, and they plugged it in up here rather than finding the antiderivative before plugging in. Say it again? This thing is just the notation of you saying, I am plugging in 1 and subtracting 0, plugging in 0 and subtracting those. No, if you were able to do it without writing that, that's fine. But that's what that notation means. That's all. Okay. All right, second example. We're going to say find the area enclosed by y equals x squared and y equals 2x minus x squared. Find the area enclosed. Sorry if it's reflecting. Give it a second. Is that easier to read that way?
I didn't see the difference.
What did you do?
Yeah, I don't know what you did.
I turned the light off so that it wasn't reflecting off the paper as much.
I can see it now.
Okay. All right. So let's go ahead and see the picture that we're looking at. I want you to graph both of these at the same time. So we got x squared and we've got 2x minus x squared. Yeah, they're both parabolas. A zoomed in calculator screen actually works really well for this. So if you hit the window button, here I'll put the light back on so you can see again. If you change your window so it's -2 to 2 for the x values and -2 to 2 for the y values, it makes it a little bit easier to see this graph. So What do you think they're talking about when they say the area enclosed by those two curves?
So it's
The area right there.
Yeah, this little, that little part right there. Okay. If this was a calculator inactive problem, and we had to figure out x values right here and right here, those are x values where the two graphs intersect, how would we find that by hand?
Wait, what?
If I wanted to find the x value right here where they cross, and I want to find the x value right there where they cross, because that's how I have to evaluate it, right?
You're intersecting.
You're intersecting. You're finding where they intersect. So if you were doing this on a calculator, what are you going to do? Second Calc 5, right? You're going to find where they intersect. Now, what if you do not have a calculator and you have to do this by hand? Set them equal to each other. We're going to do it that way. We're going to set them equal to each other. So we're going to say x squared. And right now the y's are both alone. I'm pointing that out because every so often you might have an equation where one equation says y equals and the other one is written in terms of x. It's like x equals y squared or something. So you have to make sure that if you're setting them equal to each other, they equal the same thing. Like this equals y and that equals y, and that's why I can set them equal with the form they're in right now. So I have x squared equals 2x minus x squared. And how would I solve that equation? Plus x squared. You guys want the x squared to be positive. That's not bad. That's okay. So x squared plus x squared is x to the fourth. 2x squared. Perfect. I almost tricked you.
No, I just don't know.
Okay, and then what else do we need to do? Don't you dare divide by 2. Subtract 2x equals 0. Because what type of equation is this I have to solve? Quadratic. How do we solve quadratics? We factor. We factor.
Take out 2x.
Take out a 2x. You have a GCF of 2, and you also have a GCF of x. So 2x, and then what's left over? X minus 1. You guys are talking like a Math 1 class right now.
We're feeling like a Math 1 class.
Yeah. So we have x equals 0, x equals 1. So when we do our integral, we're going to say this is evaluated from 0 to 1, because those were the x values that are on either side of that enclosed area. Okay. We're at the point where we should definitely be drawing a sketch so that we can see what we're looking for. So x squared starts at 0, 0. And over 1, up 1 on both sides. And then over 1, up 3. And then if you want to use your calculator to get the points for the other one, that would be okay. I mean, it's not cheating.
It's not cheating if the teacher explicitly tells you.
It's true.
Explicitly tells you. No. That defeats the purpose of it. Like, if I asked you, can I steal this eraser? And you said, yeah, I'm asking you to take it. That's not steal.
That's not what
That's exactly what you explicitly told me. No, but I'm asking the teacher.
So anyway,
yeah, anyway. That's a point.
We have the integral from 0 to 1, right? And which curve is the top and which curve is the bottom?
The bottom is 2x minus x.
Wait.
No, the top is 2x.
Yeah, you have to look at what's happening right here. So which curve is this part? That's the 2x minus x squared. So that's the top. 2x minus x squared is the top. What's the bottom? X squared dx. And then we can go ahead and find this on the calculator.
Whoa. Awesome. That's the same. How weird is everything?
All right. How are we feeling about that one so far?
Good.
I'm feeling good.
Pretty good? Okay. Since you're feeling good, we're going to do a trig one.
Oh,
No one said anything.
Why do you feel confident?
All right, find the area. Bounded by, actually, they did not say y equals. They said f of x equals sine x. F of x equals cos x. X equals 0. And x equals pi halves. So find the area bounded by f of x equals sine x, f of x equals cos x equals 0, x equals pi halves.
You good, buddy?
All right. Okay. Calculator. Go ahead and put your calculator in front of you. We're going to mess with the window first. So go ahead and hit your window button. What is the lowest x value I should see on my window? 0. What is the biggest x value I should see on my window? Oh gosh, sorry. Pi. Oh yeah, pi halves. That's fine. Pi halves. We can do pi halves. Does anyone remember what sine and cosine bounce back and forth between? Yeah, 1 and 1. -1 and 1. So I'm going to say -1 to 1. And then in here we can go ahead and do, I'm going to maybe graph these one at a time so that I can sketch it on my paper, because it's going to be hard for us to know which one's on top and which one's on bottom if I graph them together. So I'm going to go ahead and do cos x. Sorry, that's my phone. Let me project that. Okay. Cos x. I think I typed, well, I just did, these should not both say f of x. Make one of these say g of x, it doesn't really matter which one. They are not the same, they are different. Okay, so there is the curve that is used for cos x, and I know that this went up to 1 and this went to -1, so I'm going to go ahead and start drawing my sketch. And I'm going to say that this is the end, this is where pi halves is, and I know that cos, it started up here at 1, and then it kind of went down to pi halves at the end. Okay. And I'm going to go ahead and graph sine. And I can see that sine x kind of did the opposite. You guys see that?
Started from 0.
So if we're finding the area between the curves, are we finding this part down here? No. What are we finding that's between the curves?
Left side.
Yeah, the left side and the right side. Okay. So this is one where we're going to have two different integrals. Yeah. We're going to have the integral from 0 to what? Pi 4 seems like it might be right. How did we figure out where they crossed in the last problem? We set them equal to each other. So we're going to go ahead and set these equal to each other. They both equal y right now, so I'm going to say sine x equals cos x. And if we can picture the unit circle, we are wondering where on the unit circle, you're going to get this, where on the unit circle does the x coordinate and the y coordinate equal the same thing? It's root 2 over 2, which is, right, root 2 over 2, root 2 over 2, it's pi fourths. Okay? All right. So that means that this middle part where they cross must have been pi fourths. So our first one is going to be from 0 to pi fourths. And which curve is on top? Cos. So we're going to say this first one is going to be cos x minus sine x dx. And we're adding that to what?
Sine x minus
The integral of pi fourths
pi fourths to pi halves. Sine x minus cos x dx. Okay, go ahead and plug that into your calculator. Now we could do this by hand, right?
Yes.
You couldn't do this. We could do this by hand
But we're not going to.
because we'd have to find the antiderivative first, right?
Yeah.
And then start plugging things in and use our unit circle. We could do that by hand. Maybe we should.
No.
I mean, maybe, but
But let's do it for the test now. Since we don't want to do it, she's gonna
The practice might be good to do it by hand. So I'm going to give you some in a second. What's the antiderivative of cos? Sine, just regular sine. What's the antiderivative of negative sine? Yeah, positive cos. So sine x plus cos x. And this one's going to be evaluated from 0 to pi fourths. Plus the derivative of positive sine is negative cos. Good. The derivative of negative cos, negative sine. Right, Miles? Make sure you text that to whoever you're texting. Are you on your calculator? He was on. Yeah. He was on his cell phone earlier. It was. Yeah. Okay. At this point, we probably need to remember what our unit circle looks like, right? Because we're about to evaluate using pi fourths and pi halves. So what was the x and the y coordinate at pi fourths? Root 2 over 2 for the x coordinate. And root 2 over 2 for the y coordinate. What's the point at pi halves? 0, 1. Okay.
So what are we doing right now? Why are we doing
We are drawing the unit circle because that's going to help us to evaluate it by hand. We're about to start plugging these numbers in. And so that's going to help us. I forgot. We also need 0. What's the point over here at 0 radians? 1, 0. Okay, that's going to be helpful. All right. So we've got sine of pi fourths plus cos of pi fourths. And from that, I'm subtracting sine of 0 plus cos of 0. Oh, that's not a theta, that's a 0. This is me just evaluating the very first one. So I've got root 2 over 2 plus root 2 over 2. What happens when I add half of a root 2 plus another half of a root 2? I just get root 2. So this is just plain old root 2 right there. What is sine of 0? It's 0. So 0 plus, what's cos of 0? 1. So for the first one, we have root 2 minus 1. Yep, we can say that was from our first one. Plus, let's go ahead and do the second one. Now, I know these are not necessarily your comfort zone, but how are we actually doing with these? Like, not fun, but are we seeing where all the numbers are coming from? So now we have negative cos of pi halves minus sine of pi halves. And we're going to minus negative cos of pi fourths minus sine of pi fourths.
fourths come from seeing where it's at on the unit circle. Right?
Yeah, yep. So negative cos of pi halves would be what? 0. And now we're going to minus what is sine of pi halves? 1. So that gives us negative 1. And then here we have negative, and then of pi fourths. So what should that be? Cos of pi fourths. Root 2 over 2. Minus, and then we have sine of pi fourths. Root 2 over 2. So we have negative half of a root 2 and another negative half of a root 2. Negative root 2. And this was a minus in between, so we are subtracting negative root 2. What happens with this minus minus? Plus. Makes a plus. Okay. So let's look back at what we have total. We have root 2 minus 1 plus negative 1 plus root 2.
It's the same thing. Root 2 minus
2 root 2
1.
minus 2. Right? Combine like terms. So we had 2 square roots of 2, and we had 2 negative 1s. Right? Okay. So we got 2 root 2 minus 2. That's our answer. That's the exact form, right? Let's go ahead and type it on the calculator and make sure we can verify that that was right. You guys know how if you give a cat a bath, they like fight you at first, and then they just like go completely limp, and they like don't fight you anymore. It's like they're dead.
No. No.
That's how you guys are right now. You like fought me at first, but now you're like, I have no will to live. They do. They do. Yeah. They like. They like emotionally. They just completely shut down. Kind of like you guys. I know. Okay. Plus.
So how do cats pay themselves? They just live themselves in real life? That is straight up. That is disgusting. What do you mean to them?
Okay, have you guys typed it in? Or typing it in to check?
It's a lot tighter. That's not what I got.
Oh. You got the 8.28. Oh, I typed it in wrong. I typed in my antiderivative instead of typing in my integral. Hey guys, be careful when you type it in. I accidentally typed in my antiderivative instead of typing in my integral, and that made me think I got it wrong. And I just had to fix it. So our answer works, right? You can get it by the calculator if you want the approximate, or do it by hand to get the exact. But do we understand how it works?
Yes.
2 different ways of doing the problems. Yeah. Okay.
We can do it.
All right, we got one last problem. Do we need more graph paper? All right. Last example. Here we go.
And I was like, bro, this is not even the Bible. Everybody in the class was like, bro, like you said, I was like, bro, I just gotta take a picture. It was, the thing was, in our class, we had to write your name on the list.
So it says find the area enclosed by y equals x minus 1 and y squared equals 2x plus 6.
So you gotta do the 47 equal 2, so you gotta do the square root.
Yeah, so this is one where we need to see the boundaries that we're going to use, and we do that by setting them equal to each other, but they are not in the same form right now. One is y equals, one is y squared equals. So if we set them equal to each other right now, that's going to be a problem, right? So what I went ahead and did is I said, if this is y equals x minus 1, what I could do is I could take this x minus 1 that represents y and plug it into this y right here.
Ooh.
And the reason I did that is because I wanted to avoid having a big square root in my problem. That make sense? Okay. Now it's going to work out, it would have worked out the same either way. If you'd started with the square root, you just would have known to square each side, but it'll be okay to do it this way. So I'm setting them equal to each other, basically, so that I can see what my boundaries are for the x's. I want to see how far I need to find the area to get this. Actually, it's going to be a little different than that, but you'll see in a second. So this is a good place to start either way. So what should we do first? X minus 1 squared? How do we do that? We don't distribute the squared. We FOIL, yeah. You don't want to distribute the squared because if you do that, you'll get it wrong. Yeah, so be careful with that. This gives us x squared minus 2x plus 1 equals 2x plus 6. What type of equation is this? Quadratic. How do we solve quadratics? We factor. What does it have to equal before you factor? 0. Okay.
I ain't gonna front it, but she gave me one I had to do quadratic.
So we got x squared
That's a long.
minus 4x
Not one by time.
minus 5 equals 0. And if we factor this, how do we factor this?
It's got to multiply to negative 5.
Multiply to negative 5.
5 minus 1.
Yeah, multiply to negative 5, add to 4. So negative 5 and positive 1. And what are the x values? X equals 5, x equals negative 1. Okay.
Yeah, I know I messed up.
Okay, so when we draw this particular sketch, we're actually going to have 3 equations that we're drawing. We're going to graph y equals x minus 1. Then we're going to have to graph y equals the positive square root of 2x plus 6. And y equals negative square root of 2x plus 6. You're going to see in a second the point. Yeah. So this y squared is actually a sideways parabola, and this gives us the top of it, and this gives us the bottom of it, of a sideways parabola. Yeah. Okay, so let's go ahead and get ready to draw our sketch. And I'm going to start off with that straight line because I think it's the easiest to draw first. And once you've done a few of these, what I've been doing is I've been like sketching the graphs that I know by hand. Not necessarily that big, but what I would do next is I would probably have graphed this in my calculator first to see how big I should make it, and then kind of do my graph based off that, so I'm not like wasting a lot of paper. So if you do square root 2x plus 6, I'm going to go ahead and put my window back to normal. So that's what it looks like. I can see on here I have an x-intercept of -3. And I'm just graphing the points that are easy to graph.
Who's the funniest person I remember? Stop making fun of her, just like little memes.
So are we drawing it? We have our x-intercept at -3, we have the point -1, 2, and then we have the point 5, 4. And if I go back and put the negative in front of it and then graph it again, it's mirror imaged on the other side. Oh gosh. I meant to have it cross at 5-4 and I drew it through the wrong point. There we go. You guys are going to be like grunting in the background. Ah! Ms. Rice!
I got it.
You know what?
Okay. So if we're finding the area that's enclosed, then we're finding this whole thing right here. Yeah. So those points that we found at first, they're going to help us, but maybe not the way we think they were, because we thought maybe the integral would go from -1 to 5. But does it look like it should go from -1 to 5? No, it's a little bit bigger than that, right? But the -1 and the 5 are still going to help us. So the first thing I'm going to do is I'm going to say we have to think about top minus bottom, right? So the first area I'm going to break up right here.
Well, one of them is the top. Oh, that's why we did.
Do you see it? See how, yep, we had 3 different graphs, right? This is the positive square root version. This is the negative square root version. So my first integral is going to be from -3 to -1. And what curve is on top?
The positive square root.
The positive square root. Minus, what's on bottom?
Negative.
The negative square root. And we're going to add that to the rest of this, right? So what's the integral for the rest of it?
-1 to
-1 to 5. And what's the top curve? The positive square root minus x minus 1. This last one technically should have had brackets. Usually you do parentheses on the inside and then brackets on the outside if you need to. So that's the grouping symbols.
-1 to 5 is what you wrote?
Yeah, so I'm doing, the first one was -3 to -1 for this part, and then over here I can do -1 to 5. Okay, so do we see how we had to break that up just to make sure that we had one curve on top and one curve on the bottom? We didn't write one that had 3 different curves in it. We had to break it up so that we had a top and a bottom, another top and a bottom.
But doing that, how we would know that at first?
You'd be able to see it from the picture. You might not be able to see it from this part, but once we had this part written down and drew the sketch, then we could see the purpose of these numbers, like how they helped us. Okay. All right, go ahead and plug it in on your calculator. I'm not going to make you do it by hand. You're welcome.
How kind.
Yeah. Yes.
Wow, Matthew has this.
And I'm being careful that when I do that minus x minus 1, I put it in parentheses, unless you want to go ahead and distribute the negative. So I'm just making sure I'm typing it in exactly the way that it looks.
So about
Do you guys know why I put 0.000? I said 3 decimals, and we rounded it, right? This is not an exact answer. It's a rounded answer. So me putting the 3 decimals communicates to whoever looks there, like, oh, they rounded it. It just happened to look like a whole number. But it's rounded. Okay. Whew.
Didn't get that.